Mercury orbits closer to the Sun than any other planet. At that distance, it's exposed to an intensity of energy that nothing else in the solar system experiences. Every part of its surface is hit with direct sunlight that's far stronger than what reaches planets farther out. So on paper, this should be the hottest world there is. And for a long time, that's exactly what you'd expect to find. A planet that close doesn't really have any way to avoid that kind of heat. There's no distance to weaken it, no real protection to block it, and no reason for the temperature to stay under control. But when you actually compare it to the rest of the solar system, something doesn't line up. Venus, being much farther away, ends up far hotter, and not by a small difference either. So what is it about Mercury that keeps it from reaching those same extremes? The answer starts with something Mercury almost completely lacks: an atmosphere. On most planets, an atmosphere does more than just sit above the surface. It holds heat, moves it around, and keeps temperatures from swinging too far in either direction. It acts like a layer that smooths everything out, preventing extreme highs and lows. What it has instead is an extremely thin layer of particles, so sparse that it barely counts as an atmosphere at all. There's nothing there to trap heat once it reaches the surface, and nothing to carry that energy to other parts of the planet. So, when sunlight hits Mercury, the surface heats up fast, but that heat doesn't stay for long. As soon as the sun moves out of view, all of that energy escapes back into space just as quickly as it arrived. The result is a planet that struggles to hold on to heat at all, and that completely changes what closest to the sun actually means. And that's where the difference between Mercury and Venus really starts to matter. Because while Mercury lets heat escape almost as quickly as it arrives, Venus does the opposite. Its atmosphere is incredibly thick, made mostly of carbon dioxide, and it completely surrounds the planet in dense layers of gas and cloud. The surface warms up, but instead of releasing that energy back into space, the atmosphere holds on to it. And it doesn't stop when the sun moves away. Unlike Mercury, Venus doesn't cool down once night falls. The same thick atmosphere that traps heat during the day keeps it locked in across the entire planet. Over time, that shifts the balance completely. Mercury heats up fast, but it can't keep that energy. Venus doesn't need to heat up as quickly because once the energy is there, it stays. And that difference keeps building long after the sunlight itself is gone. And that contrast becomes a lot clearer when you look at how Mercury behaves from day to night. On the side facing the sun, temperatures can climb to around 430 degrees Celsius. The surface is exposed directly to that energy, with nothing in place to reduce it or spread it out. But that only tells half the story. Mercury rotates slowly, which means one side of the planet stays in sunlight for a long time before finally turning away. When it does, that same surface is suddenly cut off from its only source of heat, and with no real atmosphere to hold on to that energy, the temperature just drops. The heat that built up during the day escapes back into space, leaving the surface to fall to around minus 170 degrees Celsius. There's nothing there to slow that process or keep any of that warmth in place. So instead of maintaining a steady temperature, Mercury swings between two extremes: intense heat when it faces the sun, and deep cold when it doesn't. These extreme temperature swings lead to a contradiction that shouldn't be possible on a planet this close to the sun. Because Mercury is so bad at moving heat around, it creates entire zones that the sun's energy can't actually reach. At the poles, there are deep craters where the rim permanently blocks the sun's rays. On a planet like Earth or Venus, the air would carry warmth into those dark areas, evening out the temperature. But on Mercury, there is no medium to move that energy. The heat stays exactly where the light hits, and it never crosses the line into the shade. The result is an environment that has stayed at minus 170 degrees Celsius for billions of years, even though the surface, just a few miles away, is hot enough to melt lead. In 2012, the MESSENGER mission confirmed that these permanent shadows are filled with massive deposits of water ice. It's so mechanically broken that it can be on fire and frozen solid at the exact same time. This is the ultimate irony of Mercury. It isn't the hottest planet because it lacks the one thing a planet needs to actually hold on to its power. It's the closest to the energy source, but it's the least capable of using it. Looking at it this way, Mercury becomes more than just an exception. The amount of energy a planet receives doesn't define its environment. What matters is what happens to that energy after it arrives. It builds under direct sunlight and disappears the moment that sunlight is gone. There's no connection between regions or way for heat to move or balance out across the surface. When you look at the temperature swings, the lack of stability, and the existence of polar ice, they all trace back to this same issue. The energy is there, but it isn't being managed. It hits the surface with more intensity than anywhere else in the solar system, yet Mercury has no way to actually process it. Without a system to distribute that heat, the result is a fragmented world where absolute extremes exist side by side, just miles apart. To see how much that one limitation shapes the planet, you have to mentally switch it on. If we imagine Mercury with even a modest atmosphere, not a runaway furnace like Venus, just enough of a medium to move energy around, the entire identity of the planet would shift instantly. The surface wouldn't hit the same localized extremes it does now. Right now, that 430 degrees Celsius heat just sits where it lands, building up because it has nowhere to go. With an atmosphere acting as a buffer, that energy would be forced to spread out. On the flip side, the night wouldn't be a total collapse. Instead of the temperature plummeting to minus 170 degrees the second the sun sets, that stored heat would be held in place. Now, the reason Mercury never developed that kind of system is that it can't hold on to what it needs. With its weak gravity and its proximity to the sun, the planet is constantly losing a lopsided war against solar radiation. That energy actively strips its surface. Any gas that tries to accumulate is immediately eroded by the solar wind and pushed back into the void. Mercury is basically a machine with a missing component. Because it lacks the gravity to hold on to an atmosphere, the solar wind just sandblasts the surface and prevents any heat from ever being managed. It's the ultimate planetary irony, drowning in solar energy but lacking the hardware to actually catch it.